My slides is visible or not? Okay, then let's start the session. And so this is your first question. So you have 2 minutes time to solve this question. So the question is considered monomers of general structure CH2 CHX in the following table. Select the correct option. Plus sign indicates that monomer can be, and the minus sign indicates that monomer cannot be polymerized in general by the method mentioned at the top of the column. Okay, let's discuss this question. So the this is the general chemical structure of CH2X. Okay, so first when X is equal to uh, OCH3, then it is OMe, right? So as I told you before that this is a vinyl ether, vinyl ether moiety. So these only can be polymerized when it is through cationic polymerization. Cationic polymerization. So other than that, anything it would not be stable, because that if this type of motif uh, was present, like if it is initiated by cation, then it will be plus charge is there, then it cannot be stabilized, right? Sorry, I present wrongly. Okay, so this is the not the case. So the case would be, yeah, if this is the plus charge, then it will not be stabilized, right? And also show the full screen. Sorry. Wrong happened. Now is it visible?
Sir.
Okay. Uh, so as you can see, what I am telling, that this will not be stable, right? So if it is not stable, then it cannot propagate. It cannot propagate. So only thing no, sorry, if it is the cation, then only it can be stabilized, because this lone pair is there, so it will go there, and after that it it will form this type. Sorry for this, really sorry for this. This type of intermediate will be produced, that is actually stabilized. So that's why this OMe, when the OMe is present, only cationic polymerization can be takes place. In case of free radical, it cannot be takes, it cannot take place, okay, because it will not be stabilized then. If OM is there and there is a radical present, it cannot be stabilized through by this lone pair. However, in case of styrene, when pH is there, I mean phenyl group is there, pH phenyl group, then this is styrene. So as I mentioned before also, so styrene can be polymerized with everything. Okay, so it can undergo with free radical, it can undergo anionic polymerization and cationic also. So this free radical is possible, anionic is possible, cationic is also possible. So B is one of the right answer, uh, because if it is positive or negative or free radical, everything will be stabilized by the resonance of this ring. Okay, so this is correct one. And for the C, this is the structure. So when X group is substituted with COCH3, this is actually the compound. So it can be stabilized when you see, when this type of free radical is present, or or if this anionic charge is present, then it can resonance. And here also it can resonance through single bond, so it can be stabilized also. So only in this case, free radical is possible, anionic polymer is possible. However, if it is cationic charge, plus charge is present, then it cannot be stabilized, because it also has the delta positive charge. Okay, it will be highly unstable. So that's why this is not possible, and this is also the right answer. However, in this case, this type of structure is present. This type of structure is very unstable, because it cannot be polymerized so easily. Okay, uh, cannot be. And if it only can be polymerized with free radical, only possible with free radical. Okay, so anionic polymerization is not possible with this thing. Okay, and cationic is also not possible. So only thing is free radical. But here it was told that the free radical and anionic both are possible. So it is incorrect. So option B and option C is correct. I find two or three people have given the right answer. So other options are not correct. Okay. Do you have any question or doubt? If not, then let's go to the next one. We have 2 minutes time to answer this question. Several times I told man, please join this meeting before 7:05 because after 7:05 we are starting the uh, question answer session, and if someone join then it actually hamper the process. So please try to join before 7:05. Otherwise, you don't need to join. Okay. And also, I mean, if you are not present in this class, then also you can access this thing because we need to upload in YouTube also. So you also find this video there also as well. So I find many people have started to answer this question. Okay. Yeah, actually, most of the peoples are right. So option A is correct one. So why option A is correct one? Let me tell you. So for the thermal initiation process, thermal initiation process. So RP is actually proportional to M I hub. Okay. So actually, what is the I mean from the rate equation, what is actual equation is the Kp into if Pt by T half, right? And so uh, if the monomer concentration, you increase the monomer concentration, then Rp will also increase. Okay. And if you find the for the MW value, MW is actually Xn into M0, right? And Xn, what is this? Xn is the degree of polymerization. So it also, uh, related to the kinetic chain length. Nu is the kinetic chain length. Okay. So this is the another factor actually. Let me, I will tell you later what is this. So not for now. So Xn is proportional to nu also. So if you find the expression of nu, it is actually Kp m and 2 of f KD KTI to the power half. Okay, so this is actually then xn proportional to actually m I to the power half. And stops. I don't know what is happening now. Sorry for this. I don't know what is happening. Sorry. I'm really sorry. So, what I was trying to tell you that a degree of polymerization is proportional to m by I to the power half. Here, m is the concentration of monomer and I is the concentration of initiator. Okay. So, why is it so? Because xn is proportional to nu, and nu is proportional to this. So obviously xn is also proportional to this thing, and mw is also proportional to xn. So eventually it becomes mw proportional to m by I half, and if the m increases, then mw also increases. However, if in case of if we here in instead of monomer, they would told that the initiator, then the thing would be different. Okay, if the initiator increases, the RP value also increases here. But if the initiator concentration increases, the MW value will decrease. Okay, always remember this thing, because you just remember this formula and this formula, then it will be very easier for you, because it will help you to solve the numerical problem also and this type of problem also. So I am many people are joining now also, but after 7:30 I will deny everyone's joining. I will not accept, I will not allow them to join in this meeting. Okay, so this is the question 3. Let's try, and you will have 3 minutes for this thing to solve this question. I find so many people have started to answer this question. It's good. I'm getting so many different uh, answer. Actually, all someone. Okay, Okay, let's discuss this thing. So whoever opted for option C is actually the correct one. So why I am telling you. So what is the structure of cyclohexane? So this is the cyclohexane, right? Cyclohexane and iso one butanethiol is this is the one butanethiol and isopropyl benzene, right? Isopropyl benzene is this one.
Sir, sir, again stop sharing your screen, sir.
It happened again. Is it fine now? I think it is fine. So
Yes, sir.
yeah, one butane thiol. Okay, and this is isopropyl benzene, and last one is carbon tetrachloride. This here, carbon. So if you follow the question, they have already told that the assume the chain transfer is the chain only to solvent. Okay, so actually the I mean in chain end, I mean it the polymerization stops when the chain I mean the radical is transferring the its I mean the polymer chain is transferring its radical to the solvent. So only then the polymer stops, polymation stop. So what is happening here? I mean, if you follow this thing, this this bond, CH bond, is very weak, right? It's a very weak bond. So the CH bond is a very weak bond. So it can be cleaved. So one polymer chain can donate its electron to this thiol, right? So it can be cleaved. So in this way it can this polymer chain can be quenched. So if it this polymer chain is readily quenched, then the molecular weight will be less, right? I mean if you find that the basically the solvent is reacting with the polymer chain, then the polymer itself will not propagate, right? So the radical that is formed, that is actually the generating the polymer, I mean helping the polymer to propagate, that is actually quenching. So in that case it will not be able to prepare the high molecular weight polymer. So in case of one butane thiol, the molecular weight will be least. Okay, then if you find this carbon tetrachloride, this bond is also can be cleavable. Okay, so that's why next will be this one. Okay, this will be the lowest, and then second last second last is this one. And in these two case, here hydrogen, all the places hydrogens are present. Okay, so this is the CH bond, is it is very unstable. However, here CC bond is present, and if it is I will deny so if this type of bond is present, so it can be clipped, because if any radical or any carbocation is formed, then it can be stabilized with the hyperconjugation of this CH3 thing. And also this benzene ring is present next to the this carbon, so it can be I mean stabilized. So isopropyl benzene will be the higher, and in highest will be in the cyclohexane. So in cyclohexane, molecular weight will be highest, and then isopropyl benzene, then carbon tetrachloride, and lowest is in 1 butane thiol. So which option? Option C. Okay. Do you have any doubt in this thing? Anyone has any problem? Have any problem to understand this question? Because this is not a numerical or any informative type question. This is a question where you have to understand the problem and you have to answer the thing. So let's and understand this concept. So if you have any doubt in this concept, please ask me. No, right? Then I'm going to the next one. So this is a very short question. You have 2 minute time to answer this. So you have to basically calculate the KD value. Whoever trying to join after 7:30, I am not allowing them to join this meeting. Okay. So if anyone of your friend is trying to do this thing, ask them to join before 7:05, and next day onwards I will make it 7:15, and eventually it will be 7:05. We will start at 7:05. If one person is also there, I will start the session with that one person. If no one is there, it is also fine. But after that 7:05, I will not allow anyone to join this meeting, because for me also it is being very difficult, right? So I am solving this question and I am allowing these peoples to join in this meeting. Uh, so it's being very difficult. Okay, many people have started to answer this question. Yeah, it's basically a very straightforward question. Okay, let me answer. So whoever could not answer this thing, I am writing behalf of them. So you know the KD is the I mean dissociation of the thing, right? So from I initiator, let's say this KD and preparing m dot moment. Okay, so this is the KD. So dissociation uh, of the initiator. So if you write the rate equation of this thing, so it is basically the first order rate equation. So this is e to the power minus kd t. Okay, so the half life is always 0. In first order case, you know 0.693 by kd. Here if you do it, it will be 0.693 by t half. T half is already told that they have already told that the T half is 10 hour. Okay, so and you have to write the KD value in reciprocal of hour. So you don't need to change the unit also here. If you need to change the unit in the final exam, do it. Okay, so in this type of question this is very easy, but I mean check that the units are also same or not. Okay, and for this type of question also, if it is better if you write the unit here also. So we call it unit calculation, because when you are doing any physical chemistry course, then you should write the unit along with the number, so that you can do the unit calculation. Okay, so here there is no unit less, so we can write 0.0693 hour input, that much. So that is the correct one. Okay, so I find many people have done it correctly. It's good that I find today many people have involved themselves to, I mean, answer these questions. So it's good actually. Try. If you fail also, there is no hurry. There is no harm, because we are here to discuss the problem. Okay, if you do it, if your answer is not right, then also it is fine. Okay, so I think you don't have any doubt here. So let's go to the next one. You have 2 minutes time let's take 3 minutes time to solve this problem. 3 to 4 at least. I'm sorry. It's an easy one. Try to solve it. I mean, it is already been taught in your class, I guess. Okay, I got the first answer, but okay, it's fine. Okay, let's try to solve it. Okay, so you know that 35, 50. Okay, let's see. So you know the new, sorry, new we call it kinetic. Right. So I already told on that time I didn't told what is B and all these things. That was intentional in the previous question. So that was the equation you already know that is been taught in your lecture. So here A is the fraction of, so A is the fraction of propagating chains undergo termination by coupling. Okay, and what is B? B is the average number of initiator fragments per. Okay, now you actually do the calculation here also. Okay, there is if you take B new is equal to 2 new 2 by A, so new will be cancel out, so there will be B is equal to 2 by A, right? So there you will find 2B minus AB is equal to 2. So A is equal to will be 2B minus 2 by B. Here they have already told that the chain contains, I mean, uh, I mean the polymer process contains produced con. So actually, and the end of the reaction, the polymer produced contains 1.25 initiator fragments per polymer molecules. That is P is equal to 1.25, right? So if you, I mean, do the calculation 1.25 minus 1 by 1.25. Okay, so it will be around 0.4, right? So if it is 0.4, if you convert it into the percentage, it will be around 40%. So 40% is the answer. Any doubt? Okay, let's go to the next one. So this is a short question. Please answer quickly because there is another question is there. So that is a long one. Yeah, the answer is option A. Okay, so let me tell you why. So when the monomers is getting polymerized, here the entropy is high, and actually so many molecules are there, right? So these molecules are actually uh, getting attached with one another through various reaction and forming this polymeric chain, right? So here the entropy is low. So if you find the del S, del S is already negative, right? So for e- any equation you can know, you know that del G is equal to del H minus T del S. So if the del S is negative, and to proceed the reaction, to proceed any reaction, the DLG has to be negative, right? So this has to be negative. So now del S is negative. So T del S is also negative. So minus T del S is positive, right? So if this term is positive, then the whole value, I mean del H minus T del S will be negative, will be negative only when del H is negative, otherwise it is not possible. So del H is also negative, and we also told that the y del S is negative, right? So option A will be the correct one. I find all the people have given the right answer. So let's go to the last one. So it is a you have to do rigorous calculation for this thing. So I will suggest you to have some calculator to do this. I mean, this calculate these things, because this is a large problem. So let's take at least 5 to 7 minutes time to solve this thing, because you need time to solve this question. Start to answer. I mean, if you have partially solved the problem, I mean, the first one at least, answer it. First part is easy. Okay, I'm starting to answer this question. So, so first part, if you find, so we have to calculate the value of initiator concentration in molar after 1 hour from the start of the reaction. Okay, so if you find the rate equation uh, of this thing of the this is actually thermal initiated process. So for the thermal initiated process, you know the rate equation, and this is actually I already told that it is first order equation minus kd by kdt, right? So initiator value, initial concentration of initiator, they already told that it is around 0.001. Okay, and if kd value is already given 1 into 10 to the power minus 5, 1 into 10 to the power minus 5. Okay, and you have to calculate the t, but here it is in 1 hour and this is in second. So you have to I mean convert this hour into second. So t is equal to 1 hour, right? So 1 hour mean 60 minute, and 60 into 60, 3600 second. So there you can write second inverse into 3600 second. Okay, so there it will be this, and this second inverse and second will be cancelled out, and it will be 10 to the power minus 5 into 3600. So if you find the value in the calculator, so it will be around 0.964. So the answer will be 0.0000964. So this will be the concentration of initiator after 1 hour. Okay, let's go to the next question. So you have to value the calculate the value of x, where x is the x is equal to the steady state free radical concentration in molar into 10 to the power 8. So basically you have to find first you have to find the concentration of that mono we have to find the concentration of the this radical. So, okay, so you know that the we write actually K I and KT is equal to the same. I mean the rate constant is same, and we can write it as KT m dot square, right? From there we can write m radical is equal to Ri by 2 KT to the power half, right? And also Ri is equal to 2 F KD and initial. Here F is equal, F is the, I mean F is the efficiency of initiator. Okay, so if you put this value here, you will find 2F KD I by 2 KT. Okay, this is mean some people is trying to join now. So it will cancel out, right? So F KD by KT to the power half, and here is I to the power half. So I is actually the this one, right? So if you do it, if KT I to the power half, and here I naught to the power half, and e to the power minus, so you can write actually e to the power minus kd t to the power half. So now we have to put everything here. Okay, so radical efficiency is already they have told that radical efficiency is 0.5. So if you do zero point 0.5, kd is actually the 10 to the power minus 5, and kt is 7 into 10 to the power 7. Okay, and this is half, and I will be the, so actually you have already found the value of ki, right? I, so you, this is actually the I value, so you can write the thing here as well. So this is a 964 to the power half. So basically you have to calculate this thing. So this is in the, not the 107. Okay, so if you find this thing, I mean calculate the value, it will be around 0.714 into 10 to the power minus 13 to the power half, and this will be around 0.03, 0.031, something like that, and it will be around 0.84 into 10 to the power minus 7 into 0.031, and after that you have to calculate this thing, and it will, and eventually it will come around let me calculate. So it will be come around 0.26 into 10 to the power minus 9. uh, so x is equal to m dot concentration. So this is the m dot concentration. Okay, so m dot concentration into 10 to the power 8. So 2.6 into 10 to the power minus 9 into 10 to the power 8 is equal to 0.26. It will be nearly this. Okay, maybe there is a mistake in my calculation also. It can happen, but the actual concept is this thing. So basically you have to find this equation, and in this equation you will put all these values, and you will solve the you will solve this thing, and you will get the answer. So is there any doubt? This was the last question. This question was little bit tricky, but do you have any doubt regarding this? Regarding our today's session? Any question? Okay. If not, then okay. Good night. Bye. We will meet in the next Friday at 7.